Okay, let's go ahead and talk about solving systems of equations by substitution. So the whole idea here is, if you look into this first equation here, this first equation is solved for y. So it's giving us a value that we can use for y. It's telling us y equals 6x minus 11, which can also be read as y is the same as 6x minus 11, which means that in this second equation, instead of writing this y here, negative 3 times y, I can write 6x minus 11. And what that does is rewrite the second equation using only one variable, x. And when you have one variable, you can solve an equation. If you have two unknowns, an x and a y, you can't solve an equation. So let's go ahead and take a look at how that works. We have negative 2x minus 3 times the value of y equals negative 7. And the value of y is 6x minus 11. So now we just have to go about the steps for solving this equation. Our first step here would be to distribute negative 3 times 6x minus 11. So we have here negative 3 times 6x is negative 18x. And negative 3 times negative 11 is positive 33. We need to copy down the rest of the equation. Okay, so we have negative 2x minus 18x plus 33 equals negative 7. Then we see here that we have like terms that we can combine. So negative 2x minus 18x becomes negative 20x plus 33 equals negative 7. Then we need to subtract 33 from both sides. These cancel out. Leave me with negative 20x equals negative 40. Remember here, same sign, add them together, keep the sign, okay? And then we divide by negative 20 on both sides. And we get x equals positive 2. Now what we can do with that positive 2 is substitute it back into this first equation. Remember, when you're doing substitution, you can never substitute from one equation back into itself. You always have to substitute from one equation back into the other equation. Okay? So, y equals 6 times the value of x minus 11, and the value of x is 2. So now we go ahead and work this out. 6 times 2 is 12, and 12 minus 11 is 1. So y equals 1. We put those together into the ordered pair of 2, 1. And that is our solution. Okay, so let's go ahead and take a look at another example in which we have to do a little bit more work in order to substitute. As you can see, neither one of these equations is solved for x or y. So in order to substitute, we need one of these equations to be solved for x or y. In other words, to have the equation read x equals, and all the other information is on the other side, or y equals something, okay? And neither one of these does that. And when you decide, when you're trying to decide which equation to use to solve for x or y, you got to kind of look at what would be easiest. So for me, what appears to be easiest would be to go ahead and solve this first equation for y. Seems to be the least amount of work, because we know that in order to solve this equation for y, which means to get y alone, all I have to do really is get rid of this negative 4x, or just move it to the other side of the equation. And when we move a term from one side of an equation across the equal sign to the other side, all we need to do is change the sign. So I can rewrite this equation as y equals positive 4x plus 6. And now that I've done that, I have the value that I can substitute for y. So down here in this second equation, instead of writing y, I can write 4x plus 6. So let's go ahead and do that. We have negative 5x minus the value of y equals 21. And the value of y is 4x plus 6. So now I have to distribute this negative to the parentheses, to the terms inside the parentheses. Remember, it's just like multiplying by negative 1. So negative 1 times Positive 4x is negative 4x. And negative 1 times positive 6 is negative 6. Bring down the rest of this equation. Okay? So we have here now negative 5x minus 4x minus 6 equals 21. And we can combine like terms here. Negative 5x and negative 4x become negative 9x minus 6 equals 21. And we have to add 6 to both sides in order to get rid of this minus 6. We have to add 6 to both sides. These cancel out, leaving me with negative 9x equals 27. The last step I have here is to divide both sides by negative 9 in order to find the value for x, which in this case is negative 3, because positive 27 divided by negative 9 is negative 3. And again, like in the first example, once we know the value for x, we need to take it back up into the first equation, either the original form or the new equation I wrote when I solved it for y. Either one works. It doesn't matter which one you use. I'm going to go ahead and use this second version here. So y equals 4 times the value of x plus 6. And the value of x is negative 3. So 4 times negative 3, that's negative 12. And negative 12 plus 6 is negative 6. So y equals negative 6. And so now I just put these two together into an ordered pair of negative 3 comma negative 6. All right, let's go ahead and take a look at one more example. In this example, I have to do even a little bit more work at the beginning in order to solve one of these equations for x or y. So I'm looking at negative 2x plus 6y equals 6 and negative 7x plus 8y equals negative 5. And I have to find a way, what's going to be the easiest path for me to solve one of these either for x or y. So what I see is right here that I have a negative 2, a positive 6, and a positive 6. So these are all even numbers. So the easiest path for me here is going to be to solve this first equation for x. Because since these numbers are all even, I could divide by negative 2 very easily. So let's go ahead and take a look at that. My first step here would be to move 6y out of the way. Okay, so I'm going to move 6y out of the way here, which means I have to move it to the other side. When we move something, a term, to the other side of an equation, we need to change the sign, correct? So this becomes, I'm just going to write it over here to the side, negative 2x equals negative 6y plus 6. And I'm still not done because I have this coefficient of negative 2 on x. So I need to divide everything by negative 2. Okay? And so I end up with the equation x equals negative 6 divided by negative 2, that's positive 3. So 3y. And positive 6 divided by negative 2 is negative 3. So now here's my equation. X equals 3y minus 3. Now I can use this value, 3y minus 3, I could use it instead of x. So that's what I'm going to do in the second equation. So negative 7 times the value of x plus 8y equals negative 5. And the value of x is 3y minus 3. All right, so next step, we have to distribute. So negative 7 times 3y is negative 21y. And negative 7 times negative 3 is positives, thank you, positive 21. And copy down the rest of this, plus 8y equals negative 5. Then combine like terms here, negative 21y and positive 8y. So 21 minus 8 is what? 13? Okay, so negative 13y plus 21 equals negative 5. And I need to subtract 21 from both sides. So I end up with negative 13y equals negative 26. And when I divide both sides by negative 13, I get y equals positive 2. This is a negative 13 here. Okay, so now that I have my value for y, the y is positive 2, I can go back into the first equation, either this version here or this version here, and substitute 2 for y, and then solve for x. So I'm going to use this second version here because it's easier. So I have x equals 3 times the value of y minus 3. And the value of y is 2. So 3 times 2 is 6. And 6 minus 3 is 3. So x equals 3. And then I put these together in an ordered pair. Remember, an ordered pair is always x comma y. Doesn't matter which variable you solve for first. It's always x comma y. So this answer here is 3 comma 2. All right. I hope that this video has helped you to understand solving systems of equations by substitution.